Hey, Geometry, this is the review problems for Chapter 10. There is a portion of Chapter 10 that you will need to know the formulas for, and then there's any of the three-dimensional figures. I will give you those formulas when you go to take this test tomorrow. So anything that is two-dimensional, you probably need to know the formulas for. Maybe I'll write the formulas off to the side as we go through and do each individual problem, okay? So first we're talking about area of a parallelogram, okay? And so I'm going to say I can't spell, parallelogram is just base times height is for a parallelogram. Now, they're not going to make it that easy because they give you the base. Okay, they actually give you two numbers for a base. 6 is going from here to here, but the actual base going all the way across is 7.5, and you can get that from here. Okay, so 7.5 is going to be my base, but we have to find the height here, okay? And that's the reason why they give me this 6 value is because to find the height, I need to use like SOHCAHTOA. Or you could look at this as a 45, 45, 90 triangle, because that's what it is. And so if this is 6, then this would also be 6, right? Because like those two angles would both be 45, so that's 6 and 6. If you don't know how to do that, you could certainly do sine, and it would end up being like sine of 45 equals x over 6 or something like that. Let me see if that's right. Opposite. No, it would be tangent. Tangent 45, opposite adjacent. There you go. Tangent 45 equals x over 6. And then you would end up getting that value of 6. So 6 is the height. And if I take 7.5 times 6, it's 42 plus 3 is 45 inches squared. So for parallelogram, remember that space times height. And that is how you find that. Okay. For a trapezoid, you need to remember that a trapezoid is really base times height as well, but which base do you use? Do you use this one or do you use this one? Well, you actually use the average of the two, which is like base 1 plus base 2 divided by 2, right? Like that's how you find an average times the height. They write it, I think we had it before, as 1/2 height times base 1 plus base 2, which is the same thing. They're just taking the half and putting it with the height instead of whatever. But that's really what it's based off of, is the average of the two bases, and then you take that times the height, okay? So let's just use this formula that we're used to using. 1/2, the height is 5, and then the two bases added together, 21 plus 12.5. Half of 5 is 2.5, and if I add those two together, 21 plus 12.5, 33.5 times 2.5 is going to be 83.75 feet squared. There we go. I'm not writing these over on the line, but it doesn't really matter. Okay. For a kite and a rhombus are going to have the same formula. So I'm going to do kite and rhombus. And that is 1/2 of the first diagonal times the second diagonal, okay? And it doesn't matter which one you designate as D1 and D2. So I'm going to put D1 as being 4, because half of 4 comes out really nice, okay? Half of 4 is 2, and 2 times 9.5 would be 19 millimeters squared. So that is that area, okay? This one is half of D1, D2. I guess it doesn't really matter. I'll put the 5 first. 5.6 here. Half of 5 is 2.5 times 5.6. 2.5 times 5.6. Oh, I cannot type. 2.5 times 5.6. 14. There we go. And they say rounded to the nearest tenth. That's not really, doesn't really even need to be rounded, because that's exactly what it is 14 feet squared. So, area of a triangle. Okay, these are all formulas that you should look back on, okay? Triangle is 1/2 the base times the height, or they say base times height divided by 2, whichever one you want to go with. So 1/2, the base is 10.5, the height is 5. Half of 10.5 is 5.25. times 5, if you want to do it that way. And let's see, 5.25 times 5 is 26.25 centimeters squared. Okay, make sure that you're going through and you're calculating these on your own to make sure that you get the same answer as me, because I could do it wrong. Some of these might be wrong answers. I have no idea. And also make sure that you do that so that you know how to type these into your calculator. Okay, let me get my formula sheet. These formulas down below here where we do three-dimensional figures, I do not expect you to have those memorized. I will give you a sheet for that. So volume of a cylinder is what this one is 2, pi r squared h. There we go. All right, so the radius is 2 and the height is 4. So pi times 2 squared times the height. 2 squared is going to be 4. 4 times 4 is 16. So I can just type in 16 times pi into my calculator. And let's see what we get. I got 50.3 feet squared. And to the nearest tenth is 1 decimal place. So just go by that, okay? This one is surface area of a cone. I call it SA. They, for some reason, call it T. If you're looking back on that formula sheet or whatever. They call it T for surface area. I don't know why. But a cone is pi RL, which stands for the slant height, plus pi r squared, okay? Now, they do, in fact, give me the slant height, okay? If they were asking for the regular height, that would be this guy. And to find that, I would have to use the Pythagorean theorem. But I don't in this case because 8 is the slant height, so I can just plug that in. Pi times 3 times 8 plus pi times 3 squared. Okay, now I'm going to do some fancy stuff because I don't like typing in any more than I need to in my calculator, and most of the time my brain can work like faster than I can type. So, I mean, I just do it this way. So 3 times 8 is 24. So this is 24 pi plus this would be 9 pi, and 24 plus 9 is 33 pi. So all I have to do is type in 33 pi into my calculator, or 33 times pi. Okay, you can type the whole thing in. It doesn't matter, but I like to do some of that stuff in my head beforehand. 103.7 centimeters, and this is squared. I was wrong in this last one. This should be cubed because we're doing volume. Whoops. So fix that. That should be cubed right here. Okay, I did that wrong. I labeled that wrong. Some of you guys are like screaming at the screen like, you didn't label right. Well, I fixed it. So there you go. All right, so cubed, squared, surface area, there you go. Backside, number 10. These are the doozies, okay? These are going to be the ones that are going to be really icky. You'll have one of these on your test, okay? So what I'm going to do is, this is an octagon, okay? So it has 8 sides, right? 8 sides, keep that in mind. All right, so there's going to be 8 little triangles inside of here, okay? We're going to find the area of one of those, and then take it times 8, okay? I know that this bottom is 7, all right? And then what I can do is, I'm going to look at it like this, okay? This bottom whole thing is 7, which means that if I separate him into a right triangle, this is 3.5, okay? So that's how that works. And I know that if I'm trying to find the area of a triangle, it's base times height divided by 2, or 1/2 the base times the height, okay? I know that the base here all the way across is 7, right? So 7 times the height divided by 2. I just need to find out what this height is right here, okay? So what I can do is I can look at this triangle right here, this one that I have highlighted in blue, and this angle. We can figure out what this angle is, and then I can use SOHCAHTOA to find out what the height is. If this bottom side is 3.5 and this is the height and that's the angle, we can figure out what the height is. Okay, so let's talk about what that angle is. If there are 8 of these all the way around, 360 divided by 8 is 45, I believe. Ugh. So this is 45 degrees. Now, that means that if I split it in half, this angle right here, just this one, is 22.5 degrees, which is ugly, but, you know, it's going to be okay. All right, so we've got 22.5 degrees. This 3.5 is the opposite side, and this is the adjacent side. Okay, we don't have to find the hypotenuse side. We don't care about that. Okay, so opposite adjacent means I'm going to use tangent of 22.5 equals, the opposite is 3.5 over h. Okay, and then I'm going to swap these two to find the height. 3.5 divided by, this is a really intricate problem. Okay, so if you need to go back and watch this example again, you just do that. 3.5 divided by tangent of 22.5, and I got that the height is 6.27. Let's go. So height is 6.27. I'm going to take that times 7 and divide by 2. And I got that each one of these has an area, this whole thing has an area of 21.96 units. I'm going to take that times 8 because there's 8 of them going all the way around. And that should finally give me the area. I got 175.7. I did not round to 1 decimal place until I got to the very, very end. The rest of it I kind of left as, or tried to leave as 2 decimal places if I could, because I want my answer at the very, very end to be the most accurate. So there's that. That one's going to be the hard one. So study him. He's going to be the doozy. Okay. All right, they want area of a circle if it has a circumference of 20 pi. All right, circumference is diameter times pi. And so if I know that this is 20 pi, then that must mean that the diameter corresponds to 20. Diameter is 20, okay? Now, area of a circle is pi r squared, okay? So you need to remember these formulas. For a circle, area is pi r squared, and circumference is diameter times pi, or 2 pi r. Okay, so 2 pi r and pi r squared, they look similar to each other. They both involve a 2, they both involve a pi, they both involve an r, but area is always units squared. So that's why, that's how you can remember that that's a square. Okay, all right, so if the diameter is 20, then the radius is 10, and then all I have to do is plug in 10 into my formula, and I get, like, this is 100 pi, which is going to be 314.142 units squared. That's what he will be ish if you type that in. Okay, so that was number 9. All right, are we getting close? We get 15 of them. Perfect. 15. Okay, now number 10. The area of the shaded sector. Okay, if I were to find the area of the entire circle, I would do pi r squared. Okay, and the radius is 25. So pi times 25 squared, whatever that comes out to be. Let me get it as a decimal here. 25 squared times pi, and I get a huge number. Is that right? Let me do that again. Times pi. Yep, 1963.5-ish. Okay, but I only want 70 degrees of it. Okay, so this is 70 degrees. And so I take him times the fraction of the circle that we want, which is 70 out of 360. So times 70 divided by 360, and I get 381.8 inches squared. That is the area of that section. We did this in last chapter, in chapter 9, where we did circumference, and it was kind of the same thing. You took circumference and you took it times the fraction of the circle. So this one is just going to be the area formula for area times the fraction of the circle that I want. So that can help you remember how to do these problems. There's that little slice of pie, well, it's not a little, that's a pretty big chunk of pie, of the pie that you are wanting. So the area times the fraction that you want, okay? All right, this is one of those composite figures, and like we have 2 things going on here. We have the area of a rectangle, and then what I'm going to do is I'm going to lump out the area, so I'm going to subtract the area of this semicircle, okay? So I kind of have that thing going on here. A rectangle is base times height, and a semicircle, the area of a circle is pi r squared, but a half of a circle is going to be minus 1/2 pi r squared. So the base of this rectangle, I'm going to say is 9, and the height is 4, okay, minus 1/2 pi, and the radius of this little half circle, this whole thing would be 4, which means the radius or half of that would be 2. So 2 squared, okay? All right, this is 36 minus, if I have 2 squared, that's 4, and half of 4 is 2. So I just have to take 2 times pi and subtract that from 36. Okay, so 2 times pi is 6.28. I should have known that, okay? And then minus that from 36, and that is 29.7, what are we in? Feet squared. So that's one where you're taking the two shapes, finding the area of each of the shapes, and then you're subtracting them. Sometimes you're taking the area and you're adding them, but this one you're subtracting them, okay? All right, number 12, if the triangles shown at the right are similar, what's the value of x? Okay, so the deal here is that the area, whenever I put the area of one over top of the other, that's equal to the scale factor squared, okay? So if I do the scale factor, I usually do the ending one over the beginning one, so like 96 over 34. That's going to be equal to, I'm going to go over here, x over 10 squared. Like I take the scale factor, x over 10, that's the scale factor. One in comparison to the other is equal to the areas in comparison, but I have to square it. So the deal here is when I take the square root, I have x over 10 is equal to the square root of 96 over 34. Let's see, 96 over 34, and I can square it, and it's like something like 7.97-ish, okay? And then what I can do is I can just take it times 10, and that would be 79.7 would be what x is. Is that true? That seems really huge for x to be. Did I do that right? X over 10 and 96 over 34. Square root. Let me check that to make sure. 96 divided by 34. Square root. No, wrong. This is not 7.97. I don't know where that came from. 1.68. That sounds better. That sounds way better. So here we go. X is going to be, if I multiply by 10, 16.8. There we go, inches. That sounds way, 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 way better. 70 something was way too big. All right, so there's that one. Number 13, it's the same thing again. If I'm trying to find the area over here, we can call that guy x, okay? So I'm going to say x over 384 is equal to, I would do 8 over 24. It's just like setting up a proportion, right? So 8 over 24 and x over 384, except this guy I have to square before I get the area. To get the area, you take the scale factor and you square it to get area. So I'm going to take 8 over 24, and I'm going to square it. 8 divided by 24 is a third, I think. Yep. And if I square that, I get 0.1 repeating, x over 384. And if I multiply by 384, I can get 384. I get 42.6 repeating, or 42.7 is in inches. Let me check to see. Does that look reasonable? 42.7 inches squared? Probably. That doesn't seem abnormally huge. Okay. All right, number 14. A circular pizza has a diameter of 16, which means the radius here is 8. Okay. Each slice of pizza has a central angle of 45 degrees. What is the area of each slice? So I'm trying to find the area. And this is exactly the same as what we did up here for this chunk. So we're just doing the same thing again. To find the entire area, it's pi r squared. And we know the radius is radius is 8. So pi times 8 squared, or 64 pi. And that comes out to be 64 pi. 201.1-ish. And I don't want the whole thing though. I only want 45 degrees of it. Or actually 45 degrees is 1/8 of the circle. So I'm going to take it times 45 and divide by 360, and I get 25.1 inches squared. That's what he is. Okay. All right. Last thing, number 15. Oh, and I had to do surface area, didn't I? All right. So surface area of a sphere. Surface area of a sphere is 4 pi r squared, except I don't want the whole sphere. I only want half of it. So I'm going to divide that by 2, which is 2 pi r squared. Okay, now the problem with this is that when you take a sphere and you cut it in half and you talk about the surfaces, really we're only taking into consideration this outside surface, but it actually has, now that I've split it in half, another surface exposed, right? Like that bottom surface, which is a circle. It's like a circle on the bottom. And a circle is pi r squared. So what I have to do, this is kind of weird, is I have to take the 2 pi r, which is the surfaces are on the outside, and I have to add another pi r squared, which is the bottom, onto it, right? Because now it has that surface exposed that wasn't originally. So 2 pi r squared plus 1 pi r squared is actually 3 pi r squared. So the surface area of a hemisphere is 3 pi r squared. Now, if I was doing the volume, I would just cut it in half because the volume doesn't matter that there's that extra surface exposed. But surface area, you'll have to add that other surface on the bottom of it. So we have 3 pi r squared and 3 pi, and the radius is 11. 11 squared is 121, which makes this 363 pi, which is, I don't know, 363 times pi, big number, 1140.4 inches. We're doing surface area squared. Okay, so again, you'll have those formulas for any of the ones that are three-dimensional figures, but you'll need to remember the two-dimensional figures. Okay, so that's lots of things to probably remember, but some things that you don't have to worry about. Most of these you already know. So at least, parallelogram, trapezoid, kite, and rhombus. Make sure you remember those. Study those right before the test, okay? There you go. I'm not going to do the bonus with you. You can try the bonus on your own if you want. There you go. That's all I have.